In this video, I'm going to show you how I turned this 4-inch round aluminum blank into a wheel adapter. I used my highly modified, cheesy Chinese 6040 CNC mill. Started with a 3D printed prototype, and by using 3D printed fixtures, we're able to create this milled hub adapter. It's got a raised portion here that centers itself in the wheel, holes to mount the wheel, and then it's got a different hole circle that mounts onto the wheelchair motor, and these slots to access with a wrench. And did all this stuff with this funky 3D printed tooling. And this one can bolt it into place and turn it, and each one of these you run the same program to cut this slot, and really quite happy with it. Here's what it looks like mounted to the motor and on the wheel side. So if that gives you any interest, watch the video and I'll walk you through all the steps. This is the first setup where I'm just marking the 3 holes on the top of the aluminum block. When it's done, it'll look like this, and that gives me 3 locations. I'll tap those with a 1/4-20, and then I'll use some screws, and that'll allow me to put the fixture in the 3 orientations to do the side slots. I've got this set up. It's centered on the marks that the CNC made. And then I've got the depth set up so the drill won't go in too far. And then I'm drilling that with I think it's a 6.3 millimeter, which is maybe a number 7, which is correct for a 1/4-20. This is just a tooling hole, although it is in the exact center of where the motor hub will be. So that process worked pretty well on this one. Just doing some check measurements to the outside: 16.12, 16.13, 16.13. I mean, that's close. Hole to hole, we got 60.10, 60.18, and 60.11. So we're only 0.08 of a millimeter. That's pretty close. So I've got the 3 threaded tapped holes pretty much in the right place, and then I 3D printed this fixture. It's got countersink holes in it for 1/4-20, and it should line up with that. We'll get that mounted. Now what we've got is the round piece bolted to this fixture, and the important thing here is that from the center, this one screw is at exactly 45 degrees. That'll minimize. There's one hole here that's not critical at all. Another hole here that's not critical. But then there's a hole right here and right here that are very close, and we want to make sure those are spaced out, and that's for the 4-hole pattern that's going to be on the wheel. So now what we'll do is take this over to the mill, and we'll get it centered up. Hopefully do a little better job than last time, and we'll have the mill plug out 4 little starter holes like before in exactly the right spot. Okay, I got a little out of order here. I marked these 4 holes that'll be the threaded holes for the wheels, but I forgot that I need to make a centering hub on there. So I'm going to start the cut for the centering hub now. And so this is going to be, it's a 1/4 inch, 2 flute carbide bit. They're taking a 1 millimeter depth of cut and 2.5 millimeter overlap. So we'll check in with it a little bit. Fully engaged now, it's doing its thing. So looking at the 3D printed prototype, what we're doing now is we're cutting this step. And then I'll have to go back in and rerun the program that'll mark those 4 holes, take that to the drill press and drill and tap those. They'll be temporarily with 1/4 20 because I'll put it back on another flat fixture so I can mill this backside. Complicated setup.
So we're almost through the first time around. Cut should lighten a little bit if it intersects its own path. It's cutting almost 0 now. Now it's moving out, taking 2.5 millimeters horizontally, 1 millimeter vertically. So we'll let that do its thing. It might be getting a little hot, picking up, or maybe the bit still, it's picking up a little bit of flake there. A little bit of piece there. Okay, I kind of didn't like that way that was cutting. There's a little debris between the workpiece and this fixture. Also, the 3D printing, you know, that first layer might have a little error. I put a piece of cardboard in here to shim it. I used a straight edge across the top, measuring down to the table to get it pretty close. When I took it off, it's also getting pretty warm, so I'm going to chalk it up to a worn bit, and I've got a very fresh new bit in there. So hopefully between all those changes, the spiral upcut, white side, 2 flute, 1/4 inch. Hopefully between those changes, we'll be in good shape. Fixturing is a bear. Okay, we're about 2/3 of the way through the second pass. We're taking off 1/4 inch, which is 6.35 millimeters. So 6 passes of a millimeter each, and then the final pass would be 0.35 millimeters. So it occurs to me that these feeds and speeds and the cut depth and all that stuff and no cooling might seem really weird to a real machinist, and probably they are. Keep in mind that this is a super lightly built aluminum structure. It is not rigid at all. So what I depend on is taking very small chips that don't deflect anything on this structure. And, you know, so there's very small forces involved. And that's why we've got this, you know, basically super slow, ridiculous thing. It's not meant for doing this, but it's better than the machine that I don't have. So just for fun, I decided to engrave some words on the hub. This project's named Misery Mower. This is a 132 inch diameter taper ball tip bit. So I'm going super slow with very small, I think a 1/4 millimeter depth of cut, hoping I don't break it. Okay, it finished up engraving with that tiny little 1/32 bit. That looks pretty cool. That's fun. The finish out here with a 1/4 bit, it is just silky smooth. You can't feel any tooling ridges at all. Very nice. So at this point, we've got 2 of them with the engraving on them. Pilot holes here. This one's got the engraving, and I've already threaded those holes. I'll thread these holes once the machine's busy again. On the back side, they've got the threaded pilot holes that fit the motor hub. And on the front side, there's the threaded pilot holes. I'll enlarge those and make them 9/16. So the next step is to cut these access slots, and then that nut will go down to this slot, and then there's room inside this slot to get an open-end wrench on it to tighten it up. So we've got to duplicate this slot on this metal, and there's the 3 pilot holes for the hub side. So we know that if we just go straight down here with that shape, we'll have to zero it out from that edge. Go straight down there from that shape, then the slot will be in the right place. So we'll set that up. So we have this piece set to cut the slot for the wrench access to that nut. Got the full nose 1/4 inch round bit in there. It's set for 1/2 millimeter depth of cut and 1/2 millimeter overlap. So and see what happens. It's pretty darn slow. We might speed it up some. Okay, I sped it up a little bit. Seems to be handling it fine. Not in a huge hurry. Unfortunately, this software doesn't give you any kind of estimate of how long it's going to take to run it, but we'll find out. The first time I've used one of these 1/4-inch round over bits, so hopefully it'll keep cutting like this and will not be any excitement. Well, this slot's getting pretty deep. I measured, it should be okay, but that collet nut is getting pretty darn close to the top of the part. This is finished up, and if you look in there, you can see the hole. That's where the bolt's going to come through. That area that's not shiny is because the side of the bit here is rubbing on it. So apparently the shaft of the bit is just the tiniest bit larger than the actual cutting surfaces. So there's the piece, and there's the slot cut in it. Be able to access that nut. I think that's going to work fine. Looks pretty darn good. The piece is hot to the touch. I mean, I can hold it, but it's right on the edge of being comfortable. So I'm going to switch over to the other hub and let this one cool. It takes about 1.5 hours to cut that. The nice thing about this setup is I just loosen these 3 bolts, stick the opposite cool piece in there, and push go. There's hardly any setup time. I don't have to sand anything. Another thing about these this dumb mill, which, you know, I put it down a lot, but it actually gets the job done, is by using these really slow feeds and really shallow cuts, even though it takes a long time, it allows me to use 3D printed fixturing, which I actually fixtured something once with just some double-sided tape. If double-sided tape would work, 3D printing would probably work. Just finished up the last of the 6 side slots. Made a lot of mess. So I have both hubs machined up to this point. You've got the tapped holes to use for tooling, and these holes will be bored out for a 3/8, I think it's a 3/8/16 for the wheels. And then on the other side, we've got these clearance holes, and these holes again are just for tooling right now. They'll be drilled out to M8. And after they're at M8, it'll plug onto here, and we can drop a nut down in that slot and anchor it. I cannot get this hub off the shaft. It's like Loctited on there. I tried to pull her, and I didn't want to do heat because I didn't want to ruin the seals and stuff. But then I thought, well, it's very securely attached. Why not just attach to it? Instead of trying to attach the shaft, we'll attach to the hub. So that's my plan. All right, so the next step is to line up this 3D printed plastic fixture plate, stick it in the mill, and program the mill to mill out that hole and to put this chamfer on it. So that's what I tried to set up last night. And this is where this video turns from a documentary into a comedy, or maybe a tragedy. A little earlier, I had a bit in here and I was doing some milling, and I said in the video, I said, boy, that bit looks like it's dull because it's pushing up a ridge. Well, I've got a 2-step pass to machine on here, and there'll be I can use a coarser bit to do the first pass, and then a round over bit on a finer grid to make it smooth. So it's milling away last night, and because this bit was dull, it started getting hot. And then once it was hot, the aluminum started sticking. And when I first got here, the bit had welded itself in there. And here's a picture of, I had just manually turned the Z-axis up, and you can see it pulling away with all the strings. So basically what happened is this piece got so hot from the bit being dull and being too aggressive on my traction that the bit was basically just spin welding itself into here. Kind of a mess. So lessons learned is, when I see that a bit is dull, I need to just stop using it and not think to myself, oh, it'll be fine. So we're cutting now with a little less aggressive pass, taken a 0.5 millimeter depth, 1 millimeter sideways, and got the sharp spiral cut in instead of that dull straight cut. I didn't bring up how this thing eventually shut down. My theory is that after the aluminum stuck to the bit and basically stirred up this mess inside this whole thing, kind of welded itself there. And then I believe this is a 1500 watt spindle, and it's getting driven by this 1500 watt UPS. So when I came in, that was giving an error, an overload error, and it was shut down. And you can see right now it's only at 12%. And it's cutting and moving the motors and everything. So I think it kind of worked as basically a resettable safety fuse, because once that spindle started drawing a ton of power compared to my usual cutting, that was enough to trip the UPS. So that's what shut it down and kept anything crazier than just a melted fixture from happening. So I'll let this go for a while and check the temperature. With this sharp bit and less aggressive cuts, this piece is just not, I mean, it's cool to the touch, maybe the slightest bit warmer. So this is progressing around. I just took a thermal camera shot and it's showing this is about 100 degrees. And yeah, it feels warm, but not horrible. 100 degrees out, not see. I'm gonna vacuum all the crap out of it and see that doesn't help. So it's cutting nice and clean. I can comfortably leave my hand on it. Kind of at the limit. Maybe I'll shut it off and just pause it for like an hour or so. Okay, kind of exciting here. We got the center hole finished up, and it's starting doing the round and round and round to make that big bevel on the outside. Okay, that roughing pass with a square bit worked out. It's kind of interesting. These, you can feel the steps on there. I've got the roundover bit on and got the Z zeroed, and I'm about to fire that up and let it do the smoothing pass. So I finally finished up the center hole, and now it's working its way around the outside. So the outside diameter, that part of the hub, is 3978, and grabbing the inside diameter of the mill piece for 3977. So should maybe fit. Might have to sand something a little bit. So that pass is done. Very nice chamfer on it. The hole is all drilled out or bored out or machined out or whatever you want to say. And I'll pull it off the fixture. There's the piece, and see how the fixture bolts on there. At this point, all that's left to do to this one is to drill these out to 8 millimeter unthreaded, and on the other side, drill these out and tap them for 3/8/16. Pretty darn close to what the model came out with. One thing that's a little weird is when I got the stock, the aluminum stock was a little thicker than I needed, and since I did all my machining from each side, it grew a little thickness in it. Not the end of the world, just gives a little more thread grip for these steel bolts threaded in the aluminum to have. Okay, that's an adapter bolted up to the hub and doing its thing. It is not exactly perfectly centered, but you know, for the speeds of this mower, I think it'll be all right. So this is what the wheelchair hub to hub adapter looks like. I've basically got a long stud. It's pretty strong, 8.8 or 10.8 or something. And then got a lock nut on here. Eventually this lock nut and where the stud goes through the wheelchair hub will be Loctited in with some blue Loctite. And then basically what you've got to do is tap this adapter on slowly, and as you tap it on, you finally get the thread started. Then once you get the thread started, you take a couple of
wrenches with a wrench, and then rotate it a third of the turn and do another wrench. Eventually it pulls down tight all the way around. So I think that works all right. I'm sure this hub is steel. It looks like it's forged, so I'm sure it's pretty tough. I've got, over a 1/2 inch or right at 15 millimeters of material there. And on the back side, well, it's captured everywhere except for the slot, so I think it'll be pretty strong. The bolts that anchor the wheel are 3/8/16 coarse threads. On this side, there's almost exactly 1 inch, 25.49 millimeters, just right at 1 inch. So yeah, I think this will work. So I got to thinking about the wobble that I showed when this was rotating. I thought, hey, hold it, I've got a dial gauge. So I got this set to 0 here, and that's the lowest spot. And then rotate it around. It's about the highest. So it's about 25 thousandths from the low spot here to almost directly across the high spot. And the low spot pretty much lines up with a little shim in here, 20,000-ish maybe. That might level it out a little bit. So may play with that if I can find some shims. Otherwise, I may not. And putting that wheel on there, it's satisfyingly unnoticeable wobble. So I can live with that 0.5 millimeter spacer in there, and we'll let that do its thing. Awesome.